Namaskar, my dear friends. Let us continue the discussion on MSPM0G series, MSPM0G series microcontroller. We have taken 3507 and 64 pin LQFP package. Okay. So we have already discussed some of the pages of this particular circuits. So as you know, the microcontroller that we have taken for the design is MSPM0G3507. And as you have already seen, what are the different, like applications of this particular microcontroller is there, like in basically motor control or home appliances and all these things. Okay. You also have seen maybe these are the devices that is available with this particular MSPM0G series. Okay. MSPM0G series. Okay. So as you can see, if you talk about 3507, 3506, 3505, all of them are actually same device. Just the thing is they have a different amount of flash memory. Okay. So the device that we have taken is the highest one, which is having 128 kilobytes of flash. Similar to that, in our next session, we will see a 48 pin LQFP package as well. We are seeing right now 64 pin LQFP package. Okay. In the next session, we will try to understand 48 pin LQFP package. If you want to reduce the number of pins to, let's say, 32 pin, then you can go ahead with 32 pin VQFP package as well. Okay. But basically, our aim is to go ahead with, 64 pin, this one and this one. So let us open the circuit. So as you had already seen, the microcontroller and their pin configuration and all these things are already made properly. Similar to that, we had seen programming, and we had seen also the low frequency oscillator and high frequency oscillator and all these things. Then we had also seen about the reset switch. Similar to that, we had seen in last time how we are going to run our buzzer, that audio buzzer for alarm purpose or something like that. Then about my IR sensor, like infrared sensors. Then we had ambient light sensors for using like pin photodiode and all. And the op amp that is used is internal op amp of the microcontroller. Similar to that, we had seen how we can check our voltage levels as well, like 5 volt is this one and 3.3 volt is this one, that is VCC and VDD. So by having a voltage division and then passing it through the voltage, voltage buffer, and after that we have filter circuit. Okay. And then send it to your ADC of your microcontroller. Okay. Similar to that, we had also seen SPI using, EEPROM using SPI, as well as EEPROM using I2C communication protocol. Okay. So SPI interface as well as I2 interface, both are done. Now we had also seen this one, like we have the PWM interface to output connector or something like that, you can show. Similar to that, we have ambient light sensor with I2C interface. So this is from Visa technology. Also, we had seen one, potentiometer that can be varied and you can send the signal to your ADC. Similar to that, we have connected one LED to indicate that my 3.3 volt is available properly. If you talk about some user IOs, so we have 3 LEDs here that is going to have RGB LEDs, which is being driven by the MOSFET, that is LED user 5, user LED 5, user LED 6 and user LED 7. Similar to that, 3 more LEDs has been connected, which is user LED 0, 1, 2, and these 3 LEDs has been connected to the microcontroller pin, and microcontroller pin is acting as a sync pin. Okay, so whenever my microcontroller pin will go low, my corresponding LED will glow, right? Similar to that, we have 2 user push buttons, so you can utilize for push buttons for doing some job. At the same time, deep switches are very useful these days. So like you can configure some of the pins based on the status of these two like pins. So let us say we have A1 and A0, so 00011011. So there will be almost 4 states that you can configure based on these two deep switches, right? And then we had like a DAC output from the microcontroller that you can take out and you can run something. And at the same time, the op-amps output also has been taken out for doing some amplification purpose. Okay, so this is how the output connector or the interface connector has been given. So this was discussed in our last session. What we'll do now is we'll go ahead with next session. So next session is we have the humidity and temperature sensor that is taken, and this is from Renesas. Okay, so in same IC we have temperature sensor as well as like humidity sensor. So this has been like taken through a voltage buffer, and then uh, we have filter circuit, and then it is going to go to your ADC of your microcontroller. Similar to that, temperature sensor also going to your ADC of your microcontroller. Okay, so this is a very simple design for your humidity and temperature sensors both. Similar to that one, a separate analog sensor is also used, LM35CA. So this is also can be used a separate like analog sensor, temperature sensors for the measurement of temperature on the board, right? Let us proceed next. So this is the page which we are going to talk about DAC. Okay, so we have used a separate DAC of 16-bit like resolution. So this 16-bit resolution DAC is being used, and this is having SPI interface. So SPI interface one more was there. So here chip select 1 is used, so that the EEPROM can also be used with same SPI, and this particular DAC can also be used with same SPI. Okay. Now, as you can see, this particular, like DAC is going to give you current output. So this current output is being converted to voltage to like I to V converter. Okay, current to voltage converter. So this I to V converter is sending it to give you, like output to 0 to minus Vref. Okay, so it is making it negative. Now we are going to, like give a little bit of a reference voltage to the negative terminal, and this is how it is going to be made minus 3.3 minus 3 volt to plus 3 volt. Okay, so this is how it is being done. However, however, this particular, like IC will require negative voltage of 5 volts. So to get a negative voltage on my board, there is a very simple technique that has been used. So this is the negative voltage charge pump that has been used. So if you give 5 volt positive, 5 volt negative will be generated. Okay, so this is how it is being converted, and this is going to give you minus 5 volt 100 milliamperes of current output. Okay. So this is a very simple technique and very popular technique to bias your, like op amps with negative voltage supply by just using a voltage charge pump. All right. Similar to that, we have used one ADR068. This is a voltage reference IC, and this is going to generate your 3.3 volt for the purpose of giving a reference voltage to this particular DAC. Okay. So this was all about the DAC. So if you want, you can like have a very closer look to how to generate a DAC like circuit and make it very best for your application design. Coming back to the CAN transceiver. So basically these days like CAN transceiver are used in automotive and several other applications as well. So what I have done is the CAN TX and CAN RX has been taken from the microcontroller side. So this is my microcontroller side, and this is going to get converted or voltage translated. So this is a voltage translator that I have used, and this is going to get translated to 5 volt logic level. Okay, and this 5 volt logic level CAN TX CAN RX is being like connected to the CAN transceiver. So this is the CAN transceiver that is used, and it is going to get converted to CAN high and CAN low signal. Okay, and this is going to go to a output connector. So this connector can give you a signal of CAN high, CAN low, so that you can have a proper communication. This particular CAN signal has been filtered, as well as these two capacitors are used as a filter, as well as they are ESD protected as well. So ESD protection is also there. However, this particular IC is already ESD protected. A separate ESD protection is also given. Okay. Now let us talk about lean transceiver. So a lean transceiver is also used. In this lean transceiver, what I have done is the UART signal is coming as my receive signal and transmit signal. And this receive signal and transmit signal is being converted to the lean bus, and this lean bus is going to go to your output connector. Okay, so this is how my output connector is going to go with the lean bus signal. At the same time, the DAC output of the IC is also being taken at this particular point, and this DAC can drive to the outer circuit. Okay. The power supply for this particular lean bus is 12 volt, or the input voltage, which can vary, like up to around 20 volt or something. That doesn't matter. However, it must be protected with a diode. So that's the reason I have protected with a irreversible diode. Okay. So this is a very simple circuit design for lean transceiver, converting your UART signal to your lean bus. Now, the most important part that comes to the, like circuit design of a microcontroller system is the power supply requirement. Okay, so the power supply requirement, what I have done is I have taken one connector which you can directly connect to a, like DC power supply, DC power supply. So this DC power supply, you can connect it directly, or otherwise these days, like adapter jacks comes, like which is, let's say, 12 volt 2 ampere, or 6 volt 2 ampere, something like that, or 1 ampere also will do the job. Okay. So what I have done is one of the regulator that is used, which is 5 volt 800 milliamperes. Okay. So this is going to convert your 5 volt 800 milliampere output. Now, one more LDO that has been used, which is going to convert your 5 volt logic level or 5 volt power supply to 3.3 volt. So this 3.3 volt will be used, which is going to be VDD. So this VDD or 3.3 volt is going to be used to supply all the logic levels and microcontroller power supply and all those things. Okay. the the amount of like capacitance that is mentioned in the data sheet might be little lesser. However, to be safer side, we have given ample amount of, like or a good amount of capacitance that is required for the circuit. Okay. So alright guys, hope you have a good understanding of complete schematic design of this particular microcontroller that we have discussed right now, which is going to be a breakthrough for, like very low cost and simple designs. That is going to be my MSPM0G series of, like, let's say 3505, 06 and 07, similar to that other part numbers as well. And this MSPM0G series schematic design is going to be a, like a fundamental of all the circuits that you are going to deal with in your, like a next design for some other applications, or wherever you need for your microcontroller circuit design. You can have this particular circuit as a reference for your design. Okay. So let me go through one by one each of the pages so that you can have a proper understanding. So this page was all about the microcontroller and the like reset and programming connector, and we have the oscillators. If you want, you can utilize external oscillator and all those things, and decoupling capacitor, and coming back to the pin configuration or pin mapping. Then we had next was we had the discrete part, like lot of, like alarm, or, like we have the ADC, a measurement of the power supplies and all those other parts. Then we had user IOs, and we have ambient light sensors with I2C. Then we have potentiometers and like LEDs, push buttons, and dip switches and all those things. Coming back to the sensor side, so we had the humidity sensor and temperature sensors. A separate temperature sensor is also used here. Then we had the DAC. So DAC circuit was there, which is going to give you output of -3 volt to +3 volt. levels. So based on the input that you are going to feed, it will give you the output. And a proper reference voltage is also generated here. And to bias the negative supply for this particular op amp, you have a negative charge pump here. Okay. Then we had the CAN transceiver and LIN transceiver. And then at last we have the power supply design for this particular microcontroller design. So if you do have any questions or any other particular microcontroller part number or microcontroller that you are using for a particular purpose, you can put down your queries in the comment box and we shall be able to give you answers as soon as possible. Thank you.